Hey everyone, how's it going? So today we're going to be talking about limits. Now, what are limits in calculus? Put simply, a limit is the value L that f of x converges to when it approaches a certain input for x equals a. Mathematically speaking, this would be written like this. Lim x approaches a, f of x is equal to f of a, or this value L that f of a is equal to. Let me walk you through a very simple example. Let's say we're asked to find the limit lim x approaches 4 for 3x. What is this equal to? And I'm just going to go ahead and tell you that it's equal to 12, and I'm going to show you visually why this is true. Now, you could have probably already guessed, I just plugged in 3 times 4 and I got 12. But let's think in terms of a limit. If x was to equal 3, we'd get 3x is equal to 9. If x was to equal 3.5, we'd get 3x is equal to 10.5. If we got x was equal to 3.9, we'd have 3x is equal to 11.7. If x is equal to 3.99, we get 3x is equal to 11.97. And lastly, let's just do something a little over 4. If we got x is equal to 4.0001, then we get 3x is equal to 12.0003. What I'm trying to say is that the closer we get to x equals 4, the closer our limit value L approaches 12, but not actually equaling 12. Here's another example. Let's say we're trying to find the limit as x goes to 0 of x squared. Well, plug in 0 squared and you get it's equal to 0. But let's think in terms of a limit once again. If x equals 1, x squared equals 1. If x equals 0.5, x squared is equal to 0.25. If x is equal to 0.1, x squared is equal to 0.01. If x is equal to, let's do something slightly under 0. Let's say it's equal to negative 0.02. Then we have x squared is really close to 0. It's 0.0004. See how it gets really close to 0, but never actually touches 0. It converges to 0. Let's do a third example. Let's say we're trying to find the limit as x approaches 3 of x squared minus 9 over x minus 3. If we try to do direct substitution, then we end up with 0 over 0. And we're like, what? Does this limit not have a value? No, it just means we have to do a little more work because 0 divided by 0 is an indeterminate form. If you took grade 12 math, you would have learned that x squared minus 9 over x minus 3 is equal to x plus 3 contingent on the fact that x is not equal to 3 because you can't divide by 0. So we don't immediately know what the value of this limit is because we can't use direct substitution. But once again, we can use the method of getting really close to 3 but not actually touching 3. So let's start approximating. If x is equal to 2 squared minus 9 over 2 minus 3 would be equal to 5. If x is equal to 2.5, 2.5 squared minus 9 over 2.5 minus 9 would equal 5.5. If x is equal to 2.9, you'd have 2.9 squared minus 9 over 2.9 minus 9 is equal to 5.9. And if x is equal to, let's do something slightly over 3. If it's 3.01, really close to 3, you'd have 3.01 squared minus 9 over 3.01 minus 3, and this would equal 6.01. So we can see that we're getting really close to 6, but we don't actually touch 6. Now, obviously, an approximation method is not an acceptable method on an exam, so what you're going to have to do is actually use math to prove it, right? So here's what we actually do. Lim x approaches 3, x squared minus 9 over x minus 3 is equal to lim x approaches 3, x squared minus 9 is equal to x minus 3 times x plus 3. So this is just equal to x plus 3. Now we can use direct substitution, and this is equal to 6. And on a graph, this is what it looks like. This is what our function f of x looks like. So let's say x equals 3 is somewhere here. And it's a little hole of a discontinuity. It's equal to 6. We're not asking what is f of 3 equal to. We're saying what is the limit as x approaches 3 for f of x equal to, and this limit is equal to 6. That brings me to something very important. F of a doesn't have to exist for the limit to exist. L and f of a can be equal, but they don't have to be equal. Alright, let's do another limit here. Lim as t approaches negative 3, 6 plus 4t over t squared plus 1. That's equal to, well, this is not a 0 over 0, so we can just use direct substitution. So it's let's just directly plug in t is equal to negative 3 for this f of t function. So 6 minus 12 over 10, that's equal to negative 6 over 10 or negative 3 over 5. All right, let's do another limit here. Lim x goes to negative 5 of x squared minus 25 over x squared plus 2x minus 15. Once again, you can't use direct substitution because this is a 0 over 0 limit, so we need to do some work. Let's factor parts of this function. So lim x goes to negative 5, x squared minus 25, that's x minus 5, x plus 5. And the bottom here, x squared minus 2x, x squared plus 2x minus 15, that's x minus 3, x plus 5. X plus 5 and x plus 5 cancel out, so you're left with lim x goes to negative 5, x minus 5 over x minus 3. And this is equal to negative 10 over negative 8 or 5 over 4. Let's try another one. Lim, let's say, as h goes to 0 of 6 plus h squared minus 36 over h. This is a 0 over 0, so let's do some extra work. So let's expand the numerator. Lim h goes to 0, h squared plus 12h plus 36 minus 36 divided by h. This is equal to lim h tends to 0. It's h squared plus 12h in the numerator. You can also factor out an h plus 12 over h, which is equal to lim h goes to 0 of h plus 12, which is just equal to 12. All right, let's look at a different function now. So lim x goes to negative 3 of root 2x plus 22 minus 4 over x plus 3. You can already tell this is a 0 over 0 limit, so we need to do some extra work. We can't just use direct substitution. Here, we're going to do something, I don't exactly remember what this method is called, but what we're going to do, let me just write this out first, is we're going to multiply the top and bottom by root 2x plus 22 plus 4 over root 2x plus 22 plus 4. This is sort of like a difference of squares thing you saw in grade 10 math, where it's like a squared minus b squared is equal to a minus b times a plus b. That's kind of what I'm doing here. If someone knows the term for what I'm doing here, please tell me. This is exactly why I'm not a math professor, lol. So lim x goes to negative 3, and then this is equal to, so this is 2x plus 22 minus 16 divided by denominator x plus 3 root 2x plus 22 plus 4 equal to lim x approaches negative 3. The numerator is just equal to 2x plus 6. And 2x plus 6 divided by x plus 3 just gives you a value of 2. So this is 2 divided by root 2x plus 22 plus 4. This is no longer equal to 0 over 0, so we can use direct substitution here. So this is equal to 2 over root 2 times negative 3, just plug in the value for x, plus 22 plus 4, and this is equal to 2 over 4 plus 4, which is equal to 1 over 4. Another important question to answer when talking about limits is whether or not the limit exists. So far, all of the examples I've been showing you have a limit that exists. But the thing is, limits don't always exist. For example, take a look at this floor function. You can see that the limit clearly does not exist whenever x is equal to an integer. The reason why this is the case is because the one-sided limits, whenever x approaches an integer, are not the same. For a limit to exist, the left-hand side of the limit as x approaches a from the negative side, has to equal the limit as x approaches a from the right-hand side, or positive side. You can see that that's clearly not the case for a floor function. For example, take the integer x equals 0. The left-hand limit, lim, as x approaches 0 from the negative side, is equal to negative 1. But this is not equal to the right-hand limit, lim, x approaches 0 from the positive side, which is equal to 0. So therefore, this limit does not exist. Now, with that in mind, let's do an example. I have two functions, two piecewise functions. The first one is f of x is equal to piecewise 7 minus 4x, x less than 1, and x squared plus 2 for x greater than or equal to 1. The second function I have is, let's let g of x equal to piecewise 6x for x is less than or equal to negative 4, and 1 minus 9x for x greater than negative 4. Let's look at A first. The question here is, does lim as x approaches 1 of f of x exist? And if so, what is the value of this limit? Let's look at the left-hand and right-hand side limits to see if they're equal. So lim x approaches 1 from the negative side of f of x is equal to lim as x approaches 1, not negative 1, from the negative side of 7 minus 4x. We can just plug in x equals 1, and this is equal to 3. Lim as x approaches 1 from the positive side of f of x is equal to lim as x approaches 1 positive side of x squared plus 2. And this is 1 squared plus 2, which is equal to 3. Both sides of the limit are the same, so as a result, lim as x approaches 1 of f of x is equal to 3, and that's our answer. Now let's move on to B. The question here is, does the limit as x approaches negative 4 for g of x exist? Let's look at the left and right hand side limits once again. So lim as x approaches negative 4 on the negative side for g of x is equal to lim x approaches negative 4 negative side of 6x, which is equal to 6 times negative 4, which is equal to negative 24. This is the left-hand side value limit. Now lim as x approaches negative 4 on the positive side, the right-hand side, right-hand limit, g of x, well, that's equal to lim as x approaches negative 4 from the positive side of 1 minus 9x, plug in x is equal to negative 4, so that's 1 minus 9 times negative 4, and that's equal to 37. These are, the left-hand and right-hand side limits are not equal, so therefore, this limit does not exist. Alright, so that concludes the lesson on limits. I've provided 6 practice problems. As you know, I only give you the final answer. I don't show you how I got to the solution. Give these a try yourselves. If you have troubles, let me know in the comments or simply email me. That's all for today. I'll see you next time.
I'll be the best escape of the in-between. I'll be the